Good morning, everyone. So, this one is a video to highlight the questions which are asked or which has been asked previously in the GPAT as well as NIPER examination from the organic chemistry. Okay, so the first question, if you see, which was asked in the GPAT 2022. Okay, so this question is of Bachmann rearrangement. How I got the idea? uh, if because if you see here, it's here, it's a ketoxime, right? It's a oxime with the two groups. You can say it as a ketoxime also. One is this one and one is this one. Okay, so there are the two groups. Now in case of Bachmann rearrangement, I already mentioned this in the you can say previous videos of the naming reaction, that in case of Bachmann rearrangement what happens, that the group which is anti to this OH, if you see that this OH and this C or you can say aromatic group which is benzene is anti to this OH. Okay, is anti to this OH. Okay, anti to this OH. So this group is going to transfer onto this nitrogen. Okay, and it will forms a amide. So if you see the last option, so this benzene ring is transferred onto this nitrogen, and it also have formed the amide group. Okay, so this option is correct. Why this option is correct? Because in case of Bachmann rearrangement, I already mentioned how you can identify it. First you have to observe this ketoxime or you can say oxime, and then you have to see that the group which is anti to this OH, if you see it, that this CH3, if you see the geometrically here, here is a carbon. So one group, this one is anti to this OH, and that's why this group will transfer onto the nitrogen, as I have also already mentioned into the naming reaction video of the Bachmann and the Robinson annulation. Okay, so D option will be correct. So this is the application part. Now this a question is from the mesomeric and inductive effect, mostly from the mesomeric effect. So in case of mesomeric effect, if you know that I have also mentioned the M plus and M minus groups. So if you know, in case of M plus group, they are called as activating group. They are called as activating group. And M minus groups are known as deactivating group. Okay, so here is a given you, they in this question they have given you this question is also asked in the GPAT. This question was also asked in the GPAT 2023. If you see here, they have give you one is ethoxy group, then NHCOCH3 group and OCH3 group. Now the answer of this question is moderately activating. Why? Because if you know the this order, I will just mention. First, the highest donating capacity is of NH minus, then O minus, then the NH2, then the NHR, which is 2-degree amine, then 3-degree amine, which is NR2, then there is OCH3 and also OCH2, and then there is a NHCOCH3. Okay, so this is the reason that as you move from the top to the bottom, as you move from the NH minus towards the NO2, the last you can say the group in this is NO2, right? Which is least, you can say, activating and highest deactivating. Okay, so this OCH3, NHCOCH3 and also OC2H5 will comes in between, okay, in this range, and that's why they are called as moderately activating. Okay, and I'm also continuing this NHCOCH3. Then it after start with the OCOCH3, and then there it comes the carbon, you can say carbonyl, which is ketone, then aldehyde, then carboxylic acids, and last it will comes to the NO2. Okay, so remember this. Then this question is also from the GPAT 2023, which is based on the you can say the SN1 reaction, and not, sorry, SN1, it's E1 reaction, sorry, not SN1, it's based on the E1 reaction. Okay, so this is a simple elimination reaction. Okay, even reaction, which I have already told you or taught you. I have already taught you the E1, E2, SN1, SN2 reaction. Okay, so this is the, you can say, application part, which is asked in the GPAT 2023. So what happens in even reaction? It is a two-step process. Okay, carbocation formation and then the removal of that you can say hydrogen, and then it form the double bond, and you know that I have already taught you. Okay, so what happens here, if you see this compound, so they have give you CH2, CH2, then there is a carbon, one side it is CH3, and here it is Br, and here it is. How I have confirmed that this one is even reaction, because of the order you know very well, that 3 degree, 2 degree, and first degree. and even if you consider it as a E2, there is no problem, you are going to get the same product. Okay, but they have not specified specifically, but if they have specified that protic solvent or a protic solvent, then you have to decide accordingly, which I have taught you in the lecture, but we will focus on this question. So what happens, this Br group will removed and it will form a carbocation. Okay, just a minute, it's not having a space, so I will mention it here. So here will form a carbocation, which is 3-degree carbocation. Which is 3-degree carbocation. Now what happens, that from the adjacent carbon, here, from here also and from here also, it can remove the hydrogen. Okay, because as we know it is a dehydrohalogenation reaction, right? So bromine is already removed. Now there is the turn of the hydrogen, so it can be removed from this side also and from this side also. Now there is a role of, you can say, Set-Zeph rule, if you know, come in the existence. Okay, or you can say now it turns off the to apply the Set-Zeph rule. So what is Set-Zeph rule is that Set-Zeph rule is telling that the compound which is going to form from the elimination reaction, or the alkene which is going to form from the elimination reaction, is going to be the product which is going to be major, is that which contain maximum alpha hydrogens. I will give you the structure so you will get more idea. Here it is CH3, I've just by mistake I have mentioned CH2. So it will gives you compound like this. Which is your second answer, second option, which is 1, this is 2, this is 3, and this is 4. So it's a 2 methyl 2 butene. Okay, in on second position it's a double bond, so it's a 2 methyl 2 butene. Why I have formed this compound only, if you see here the maximum R groups are there. So this is a Set-Zeph rule. What Set-Zeph rule is telling you that, Set-Zeph rule आपको क्या बोलता है कि जो डबल बॉन्ड है उसके अराउंड मैक्सिमम अल्काइल ग्रुप आने चाहिए, वैसा आपको जो है वो कंपाउंड फॉर्म करना है फ्रॉम द एलिमिनेशन रिएक्शन. देयर आर ऑल्सो पॉसिबिलिटी कि हमने यहाँ से जो इस वाले कार्बन से जो है वी हैव रिमूव्ड द हाइड्रोजन, हम इस वाले कार्बन से भी हाइड्रोजन रिमूव कर सकते हैं. और अगर हम इस वाले हाइड्रोजन से रिमूव करते हैं, इस वाले कार्बन से हाइड्रोजन रिमूव करते हैं, so we will get compound like this. So if you see that this one is a Hofmann product. So in case of Hofmann product, what will happen? It will gives you a, or you can say what Hofmann rule telling is, or Hofmann rule क्या बताता है कि लीस्ट अल्काइल ग्रुप जो है अटैच होंगे, ऐसा जो है वो अल्कीन फॉर्म होगा. ओके, डबल बॉन्ड के अराउंड लीस्ट नंबर ऑफ अल्काइल ग्रुप जो है वो अटैच होंगे ऐसा अल्कीन बनेगा. इन द केस ऑफ हॉफमैन प्रोडक्ट विल फॉर्म which contain least alkyl group around the double bond. Okay, so this one is Hofmann product and the previous one was कि जिसमें हमने CH2 पे से हाइड्रोजन रिमूव किया था एंड 2 मिथाइल 2 ब्यूटीन फॉर्म किया था, दैट वन इज सेटजेफ प्रोडक्ट. ओके, सो इन जनरल सेटजेफ प्रोडक्ट इज अ मेजर प्रोडक्ट. तो ये जो है वो माइनर प्रोडक्ट है. एंड जो प्रीवियस वाला था जो मैंने यहाँ पे इसके पहले बनाया हुआ था, दैट वन वाज ए मेजर प्रोडक्ट. सो हमेशा याद रखिए कि सेटजेफ प्रोडक्ट विल बी द मेजर प्रोडक्ट फ्रॉम द एलिमिनेशन रिएक्शन बिकॉज ऑफ द स्टेबिलिटी. बिकॉज उसके अराउंड 3 अल्काइल ग्रुप थे तो वो ज़्यादा स्टेबिलाइज है एज कम्पेयर टू दिस हॉफमैन प्रोडक्ट की जहाँ पे 2 ही अल्काइल ग्रुप लग रहे हैं. ओके, सो रिमेंबर दैट हॉफमैन and Setzeff rule, it's very important in the elimination reaction. And Setzeff rule is also applicable in beta elimination. We are going to take it into the lecture. Okay, वो हम lecture में हमारे live classes में beta elimination we are going to take. So वहाँ पे भी Setzeff rule लगेगा, तो it will help you there also. And the last question which was asked from the E1 and or you can say E2 and SN2 reaction, and this one was of GPAT 2022. Okay, so they have asked identify which statement among the following is true in case of E2 and SN2. So the options are: secondary substitution undergoes slow elimination and fast substitution, primary substitution undergoes slow elimination and fast substitution, tertiary substitution undergoes slow elimination and fast substitution, primary substitution does not undergo elimination and substitution reaction. So यहाँ पे आंसर है प्राइमरी सब्सटीट्यूशन अंडरगो स्लो एलिमिनेशन एंड फास्ट सब्सटीट्यूशन, मतलब कि ऑप्शन सेकेंड. ओके, स्लो एलिमिनेशन एंड फास्ट सब्सटीट्यूशन. नाउ व्हाई प्राइमरी है, मतलब कि जो प्राइमरी सब्सटीट्यूशन वाला, मतलब कि जो कंपाउंड की जो फर्स्ट डिग्री है, फर्स्ट डिग्री कार्बन वाला कंपाउंड, फॉर एग्जांपल आप ले लो एग्जांपल ऑफ मिथाइल क्लोराइड. ओके, क्लोरोमीथेन. ओके, क्लोरोमीथेन का अगर आप एग्जांपल लोगे तो E2 का जो ऑर्डर ऑफ रिएक्शन है वो क्या है, 3 डिग्री कार्बोकेटाइन फॉलोड बाय 2 डिग्री, देन फर्स्ट डिग्री एंड देन CH3 और यू कैन से मिथाइल केटायन. ये E2 का है ऑर्डर. ओके, एंड जो SN2 के केस में क्या है, जो सब्सटीट्यूशन रिएक्शन के केस में इट इज CH3 प्लस फर्स्ट, देन 2 डिग्री 1 डिग्री, देन 2 डिग्री एंड देन दी 3 डिग्री. And then in the last 3 degree. Okay, I'll just mention here. Okay, so it's a 3 degree at last. So if you read this statement, primary substitution undergo slow elimination, मतलब कि जो फर्स्ट डिग्री वाले हैं, फर्स्ट डिग्री कंपाउंड है, वो स्लो एलिमिनेशन के अंडर जाएगा बिकॉज ऑफ दिस ऑर्डर कि सबसे ज़्यादा एलिमिनेशन 3 डिग्री वाले में होता है, फिर 2 डिग्री एंड देन फर्स्ट डिग्री, तो वो स्लो एलिमिनेशन हुआ, राइट. एंड दी फास्ट सब्सटीट्यूशन, मतलब कि जो प्राइमरी है वो SN2 रिएक्शन फास्ट दिखाता है और E2 रिएक्शन स्लो दिखाता है. ओके, होप यू अंडरस्टैंड. इफ यू ऑब्जर्व दिस ऑर्डर करेक्टली और यू कैन से precisely, you are able to get your answer. Still, if you are not clear, you can ask me in the live class or in our WhatsApp group. I will answer you in that. So these are some few questions which I feel that also I will try to take some previous year questions solution, so you will get idea that whatever I have taught you till this there are so many questions has been asked previously, and also on your time also they are going to ask. So thank you very much to watching this video, and hope you are able to understand this, and we will meet into the live classes. Thank you very much.